So I need a video showing you why you would implement an operator either as a member function or a non-member function in the case where you can do that. Most operators in C++ can be overloaded, so and the binary ones can go either way for the most part. A lot of little rules I'm not going to get into in the videos. But first, before I do that, I need to drive some motivation for it. I need to show you well, we need to talk about conversions. So here I have this fraction struct. It has a numerator and a denominator. You can see I've defined a fraction on the stack here, and I've set numerator to 3 and denominator to 4, thus making 3/4. If I want to convert a fraction to a floating point value, I'll say float value gets frac.numerator divided by frac.denominator. Hopefully you're looking at these ints and you say, oh, well, if you take an int and divide it by an int, you're going to have some truncation. And in this case, 3 divided by 4, that really equals 0.75. But in int land, or let's just put a 0.75, in integer land, when I convert this floating point value to an int, the 0.75 will be dropped or truncated. So the result of this expression will be 0. That's not a behavior we want. We could fix it in a few ways. I could static cast one of these to a floating point value. That would work. But I'm going to do a cheaper trick. I'm just going to times it by 1.0f, which actually is going to have some runtime costs, so I probably should prefer the static cast, even though it's uglier to do. But either way, multiplying an int times a float will force the conversion of an integer out to a float so that this multiplication can happen. The conversion goes to a float because it's a widening conversion. The compiler looks at this and says, well, which one's wider than the other? And floats are considered wider. They can store more precision, more value, so the compiler will convert the left operand to a float and times it by a float. This highlighted portion will return a float, and the process repeats itself. We go to the division operator, and then at runtime we convert the denominator to a float because this returns a float. This needs to be a float, so we have a float. Anyway, let's print out value just to be sure that we get what we expect. And see here now we have 0.75. Alright, well that's nice, but I could see myself having to convert this fraction to a float quite often. And thus I'm either going to copy and paste this code all over the place, or I'm going to type it lots, and if I type it, chances are I'll swap numerator with denominator, screw that up, or I'll forget this floating point value out here. And anyway, it's error prone. Anytime you do repeated code, it's always error prone. That's hopefully old hat by now. I could reduce this issue by putting all this code into a function and calling that function several times. But ideally, we would put in the function that would make more sense. And so that's, again, operator overloading. Operators are simply functions. Let me show you. I want to say fraction, or not fraction, float value 2 gets fract. That's the syntax I'm aiming for. That actually kind of reads quite nicely. Take a fraction, convert it to a float. Mathematically, that makes sense, at least to me and hopefully most people. But I get the red squiggly line here. It says, hey, I can't convert a fraction to a float. That doesn't exist. So let's write one. The way you do so is you just type operator here. Notice I didn't specify the return type on this conversion operator because the return type is specified in the operator name in this case. So operator float, this is going to be the operator that converts our fraction to a float. I'm going to make it const because it's not going to modify either the numerator or the denominator. And then in here, all we need to do is return this code I have right here, the result I have, the result produced by this code right there. Okay, so now I can say float value 2 gets fract. Okay, notice the red squigglies here went away. I'll call this value 2 just to make the compiler happy. No red squigglies. We got red squigglies here though because fract does not exist in the scope, and that is because this object is the one with numerator and denominator. Hopefully that's old hat by now. I can just say numerator and denominator in a member function, and numerator here resolves to this object's numerator, and denominator here resolves to this object's denominator. I'm going to go as far as saying inline out here because this is short and sweet function, and I think it just makes sense to inline it. Alright, let's build that, run that, prove that this syntax actually works and the compiler's happy and we get the same result. You can see here 0.75 for value 2. Quite nice. What if I want to go the other way? I want to convert a float back to a fraction, or any kind of float to a fraction. That's rather straightforward. One cheap way we could do that is say fraction that takes a float value. And then in here I would write the code to figure out, well, what's the numerator, what's the denominator. The code's actually quite interesting and a little bit lengthy to put here in this example. So I'm just going to leave it out. But you get the idea that if I want to make a fraction from a float, I could say fraction frac2 value 2, like so. Okay? Now we get the red squigglies here because I have a constructor. Remember from the constructor videos, if you define one constructor, the compiler will no longer create a parameterless constructor for you. So we need to just define it ourselves. Red squiggly gone. All right, value 2. So this works. This is nice, but I can actually syntactically change this statement I've written here from saying, hey, frac2, let's call your constructor that takes a float and pass a float. I can actually say gets right there and get rid of these parentheses because they're extra. And the compiler's happy with that as well. It says, oh, frac2 gets value 2. And the compiler simply interprets this as how we had it written before. It sees that there's a constructor, a fraction, single argument constructor, takes a value, and so this assignment, it resolves this assignment to this. It's a conversion constructor. You could think of it that way if you wish to. Or it could be a single valued constructor, either one. Just to prove to you that the compiler uses this constructor, let's just put a trace statement in here. Or not cout, we're going to do fraction, float, like so, end line. And let's F10 to build it and step through this code. Step, 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 step. I'm going to hit F11 right here. Notice we're on the line that's going to assign a float to a fraction. F11, notice we jumped up to this constructor. And I'll just step over that. And you see we get the output there. Okay, so those are conversion operators in a nutshell. We can have the enclosing class define how it goes out, or we can have the enclosing class define how a value comes in and it converts. Some caveats with this I'll show in the next videos, and then we'll move back to operator overloading member functions and non-member functions.